Hi everyone, so here we are on chapter 23 and this is on electrochemistry. So electrochemistry will involve chemical reactions that actually occur in like batteries. Now the battery technology has come a long way and there's actually quite a lot of money in battery technology. If you think about it, if you just think about the size of cell phones, like way back in the 80s, the size of cell phones were much bigger back then. We used to have this like portable battery that we had to carry to the car, and you can plug it into the lighter and, then it would charge. But now the batteries are much more efficient and they are also much smaller in size. So that's how we're able to make our cell phones, laptops, and everything else much more efficient and more compact, okay, in size. And that has to deal with the size of the batteries. And so what we're going to do is we're going to be learning about electrochemical cells. And besides the term electrochemical cell, you might see the term voltaic cell or galvanic cell. And they all kind of mean the same thing, okay? And so in an electrochemical cell, this is what we're basically doing. We're going to convert chemical energy into electrical energy, okay? And that is like one way how batteries work, all right? You notice that there are chemicals inside your batteries, okay? So we're taking the chemical energy and converting it into electrical energy. Now what we're going to do is we're going to make an electrochemical cell, or we're kind of going to make like our own battery, and we're going to draw it on paper and find out how much voltage that this could output. So you would need that standard reduction table, the handout that you got in class. So you would need that as a reference. So the first one that we're going to do is we're going to put together, pen option. We are going to put together aluminum that has a +3 charge, and we're going to combine that with the copper that has a +2 charge. Okay, so you need to find these two half reactions from that reduction table. Okay, so I just want you to write them down the way that you see it on the reduction table with the voltage. So the aluminum one would look like this. And then the copper one, you should find, looks like this. The aluminum is actually a negative voltage. So right here, where I have written E naught is the voltage, okay, the cell voltage. So these values were taken directly off of the chart. Okay, so you can double check that to make sure I wrote those down correctly. Okay, now notice that the table is called a reduction table because everything on that chart is reduction. Notice that the charge is going from a +3 to a 0, that's being reduced. +2 to a 0, that's being reduced. Notice the electrons. The electrons are on the reactant side, so that's indicating that the electrons are being gained. Once again, representing that it is reduction. Okay, now in order to make an electrochemical cell, it is a redox reaction. So that means we have to have one reduction and one oxidation. So in order to get one of these equations here to be an oxidation, we have to reverse it. Okay, because both of them right now are reduction, so we have to reverse one of them to make it oxidation. And there is a method to determine which one you should reverse. When you reverse an equation, you also would reverse the sign on the voltage. Okay, and when we put these two together, what we want to get is the most positive voltage. Okay, that is our goal, to get the most positive voltage. Now, a positive voltage means that our cell works. okay, that the reaction works. And that is what we are looking for, and that is what we're aiming towards. We want the cell to work. So take a look at these voltages here. When we add them together, once again, we want the most positive value. And when we reverse one of the equations, we're going to reverse the sign on the voltage. So which one should we reverse so that we get the most positive value? Well, we should reverse this one, okay? So I'm going to rewrite the aluminum equation. So you just write it in the opposite direction. So Al will go to Al. 3 plus 3 electrons. So now that becomes positive 1.66 volts. Okay, so then I'm just going to cross out that equation because we're not using that one. We changed it. Now we can add the voltage. Okay, so if you add the math here, 6 plus 4 is 10. Carry the 1. Okay, so we get 2 volts. So this is the voltage if we make an aluminum and a copper electrochemical cell. It will give us 2 volts. All right, we're not done yet. That's just how much voltage. So now what we want to do is we want to add these 2 equations up together. And let's also just label these. So the one that we reverse becomes oxidation, and then the one that we kept the same is reduction. Okay, so we're just kind of labeling some of our stuff here. When we add these 2 equations up together, the number of electrons has to be balanced. Okay, the number of electrons has to be balanced, and that is because of the law of conservation. So notice this one has gained 2 electrons, but this one lost 3 electrons. Okay, once again, number of electrons gained has to equal the number of electrons lost. So what's a common multiple of 2 and 3? Well, it's 6, right? So we're going to multiply this whole equation here by 3, and then we'll multiply the whole bottom equation by 2. Once again, we do that because we want the electrons to be equal, okay? You will only multiply the half reactions. You never multiply the voltage, okay? The voltage is done. We are not going to touch the voltage. You're only going to multiply, once again, the half reactions, not the voltage, okay? So then, when we combine these, your electrons should always cancel out, okay? Because it's 3 times 2 is 6, right? The 2 times the 3 there will also be 6. So your electrons should always cancel out. So now when we add these, we're going to multiply through, so that will give us coefficients. Whatever's on the left side of the arrow will stay on the left. Whatever's on the right will stay on the right. Okay, so then this ends up being 3Cu with a 2 plus charge. Okay, because that's on the left side of the arrow. Let's see, this is also on the left side of the arrow, and that's going to get multiplied by 2. So plus 2Al gives us, now we go to the right side of the arrow, so 3 in front of here. And then the 2 gets multiplied on that one. Okay, so that is the overall equation when we add them up together. Now, it doesn't really matter which one you write first here, just as long as they are on the correct side of the arrow. Okay, same idea over here. It doesn't matter if you wrote the aluminum first and then the copper second, just as long as they are on the correct side of the arrow. Okay, so now what we're going to do is we're going to draw a picture kind of describing what's happening in this electrochemical cell. Okay, so I'm going to scroll this up so we have more room. Okay, so when we draw our picture, we're going to draw 2 beakers. All right, so draw 2 beakers side by side. Now, when we say electrochemical cells, like cell, like a compartment, okay, like a container, like kind of like a prison cell, okay, so cell like a container. So here we have 2 cells. We have 2 beakers, all right? Now, these beakers are going to be connected with what we call a salt bridge. So this is the salt bridge. So remember, salts are electrolytes. They're ionic compounds. Okay, so that's a salt bridge. And they're also going to have solution inside these beakers. And each beaker will be what we call an electrode. Okay, electrode. The electrodes are flat pieces of metal that are rectangular in shape. Okay, and then these electrodes are going to be connected with the wire. And then you can, if you want, you can put a V up here for voltmeter to measure out the voltage. If you want to draw a voltmeter there, you can. Okay, so this is kind of the template for an electrochemical cell. Now what we are going to do is we are going to label certain things here. Okay, the electrodes are the metals. So those are the ones that do not have charges on them. So one is aluminum and one is copper. It does not matter which one you put on which side. We will just label everything accordingly. Okay? So let's just put the aluminum over here and the copper over there. Notice those are the ones without charges. Okay? So those are the ones with the zeros on the top for their oxidation state. Now, these electrodes have to be in their own solution. So the ions are the things that are going in solution. So over here, if this is aluminum, then this has to be inside an aluminum solution. So Al, and the Al we are using has a +3 charge. Now it could be any aluminum solution. It could be aluminum nitrate, aluminum sulfate, any type of aluminum solution. So, and solutions are neutral, so then we're going to use an X to represent that it's any type of solution, but then it also has to have the opposite charge because it has to be neutral when it's in solution. Okay? Then the copper on this side has to be in its own solution, so it's going to be in a copper solution. And the copper that we're using has a +2 charge, and then it would be any copper solution, so we just say X -2. Okay? Now we need to label one of these, one container is going to be labeled as the anode, the other one is going to be labeled as the cathode, okay? So anode and cathode. And they kind of get their names anode and cathode because of like anion and cation. All right, so let me see. Let's scroll some of this stuff up here so I have more room. Now to figure out which one is the anode and which one is the cathode, we have a little saying to help you remember which one is which, okay? So it's called an ox saw a red cat. Okay, an ox saw a red cat. So this means anode is oxidation. Okay, so an ox saw a red reduction cat, cathode. Okay, so let's see. So the one that was being oxidized is going to be labeled as the anode. Okay, so that's the equation that we reversed. So the one that we reversed was the aluminum. So that means the aluminum is going to be the anode. And then the red cat, the one that is reduction, is the cathode. Okay, then electrons flow through the wire. Okay, so the electrons are going to flow through the wire. And the electrons will flow in the direction of anode to cathode. Okay, anode to cathode. So I remember it because it is in alphabetical order. Okay, anode to cathode. Or there's another saying called fat cat that will also help you remember which direction it's flowing. Fat cat means from anode to cathode. Okay, so A to C. So now we're going to draw arrows on the wire. It's going to go anode to cathode. Okay, and then we are going to put E minus for the electrons to show that the electrons are traveling through the wire. Okay, and then notice the direction that the electrons are flowing. They're pointing towards this electrode right here. So that means that the copper electrode gains mass. Okay, so we put it over here on this side. Gains mass. Okay, then therefore the aluminum side, that electrode is going to lose mass. So this one loses mass. All right, so this is basically how a battery works, okay? The electrons flow through the wire onto this electrode here, and then it's actually the ions that are flowing through the salt bridge and in the solutions, okay? So that's how the circuit works, okay? And that's how batteries work, all right? So if you have a battery, and eventually the battery will run out, okay? Eventually this battery will run out of juice and your batteries die, right? So if you have a rechargeable battery, what will happen is you plug it in, right, to charge it. So you use an outside electrical source to force the electrons back the other way, okay? And then you can reuse the battery again. So that's how like rechargeable batteries work. All right, so that is how you do an electrochemical cell. So you'll have to know how to do all of this for the test because you'll see all of this on the test. So now we're going to do another example that you're going to try on your own. So let's go to a new page. All right, so for this one, let's see. Let's do, turn my paper. Let's do magnesium. That has a 2+ charge. And I want you to put that with the chromium that has a 3+ charge. Okay? So you need to find those two on your reduction table. All right? So what you should do is you should do everything that we just did all on your own. Okay? So then you should stop the video, do it yourself, and then replay the video to check your answer. All right? So first thing you should do is look these up on the reduction table and write them down the way you see them. And you should find that voltage here to be negative 2.37. And then the chromium is negative 0.74 volts. Okay, remember you always have to reverse one of them. So we had to figure out which one we are going to reverse so that we will get the most positive value. So then we take a look at the voltages. Oops. So once again, take a look at the voltages. Okay, so which one should we reverse? Well, we want the most positive value, so we should reverse this one here. Okay, so let's rewrite the magnesium in the opposite direction. So now that becomes positive 2.37. We're going to cross that one out because we're not using it. Okay, now you can add the voltage and then you should get 1.63 volts. Okay, so that's the voltage. All right, now we have to write the overall equation, but we have to balance the electrons. Okay, notice the electrons, once again, a 3 over there and a 2 over there. Electrons have to be the same, so we're going to multiply this top equation by 2, multiply the bottom equation by 3. Oh, and don't forget, so this one was oxidation because we reversed it, and then this one was the reduction. Okay, so your electrons should always cancel. Okay, so they both would equal 6, once again, because you multiply, right? Okay, so now multiply the coefficient through over here. So that becomes 2Cr with the plus 3. And then multiply the 3 here in front of the magnesium. Okay, and we just keep going, so then it ends up being 2Cr and then 3Mg with the plus 2. Okay, so that is the overall equation. Now we need to draw the picture and label everything. Okay, so let's do that. So let's move this up so we have room. Okay, so let's draw 2 beakers. All right, 2 beakers side by side. They're connected with the salt bridge. You have 2 electrodes, 1 in each beaker. And Each beaker has a solution, and then these electrodes are connected with the wire. Okay, so now we just label everything. It doesn't matter which one is on which side, just as long as we label it accordingly. So let's do magnesium there, and the chromium on this side. They have to be in their own solution, so magnesium with the +2, and then X -2. This chromium is +3, and then X -3. Okay, the one that we reversed, which is oxidation, is going to be the anode. Okay, so remember, anox saw a red cat. So then this is anode. This is cathode. And then electrons flow. Oh, once again, we can put a voltmeter there. Then electrons flow in alphabetical order, anode to cathode. Okay, those are the electrons going that way, right? Then we look and see the electrons are pointing towards this electrode here. So that means, since they're going towards this one, that this one gains mass. Okay, this electrode gains mass. Therefore, this other one over here loses mass. Okay, and that's it. That is how we do the electrochemistry stuff. All right, so what I would like you to do now is there is a worksheet. There is an electrochemistry worksheet where you have to do, I think it's like 4 problems, just like this. Okay, and that's it. I will see you later. Bye.